We just talked about how to reduce a rational expression, a fraction with stuff in the numerator and denominator that are variable, how to reduce it into its lowest terms, which is kind of the first skill that you do with fractions. But then there are other arithmetic skills, multiplication, division, addition, subtraction, that we also want to be able to do with these. And so to get you started, put your heads together with a couple people around you. So first row, turn around, third row, turn around. And come up with an answer to this subtraction problem. You're subtracting a over 4 minus 5 over 9, where here a is a variable. Keep your bearings, treat them just like they're fractions, but try and come up with a simplified version of this difference. So your answer should be a single fraction, a single rational expression, the result of subtracting a over 4 minus 5 over 9. How did you approach this problem? We're subtracting two fractions, quote unquote. One of those fractions happens to have a variable participating in it. So what was your approach? What were your guiding principles? What did you do to subtract this one fraction from another? Yeah.
Find the greatest common multiple the greatest common multiple.
But between what and what?
Is it the factor or multiple between 9 and 4?
Between 9 and 4, so we're... by the way, yeah, so you said 36. So that means that this number that you got is bigger than both 9 and 4, which means it must be a multiple, first of all. But it's not the greatest common multiple, because 72 would also be a multiple. 720 would be a multiple. It's the least common multiple. Yeah, exactly. So the first thing you did was you looked at the two denominators, and you tried to see what number that we could try and rewrite both of these fractions using that new number. But which number would be the smallest number that we could use to get away with that process of rewriting? So you took 4 and 9, you determined that their least common multiple was 36. Great. And so then we've set a target to do probably the most important process in the addition and subtraction of fractions, which is find a common denominator. Let me back up a second. What is it about this problem that tells you that you need a common denominator?
You have a variable on top.
Oh, okay, we have a variable on top, that's true. Does that mean that we'll always need a common denominator whenever we have a variable?
No, it's a subtraction problem.
Yeah, exactly. It's a subtraction problem. Addition and subtraction problems mandate a common denominator. Anytime, whether it's a fraction with only numbers or whether it's a fraction that also has a variable in it, the rules remain the same. Right? We can't add or subtract two fractions unless those two fractions have a common denominator. So if they don't in the beginning, we have to make them have a common denominator. That's where the least common multiple comes in. Great. So we saw that we were subtracting two fractions, so we need a common denominator. Now we've decided that that common denominator is 36. What happens next? Yeah, Brandon.
Do each to the top, each to the bottom.
Yeah. So whatever we did to the denominator to turn it into 36, we also have to do to the numerator. So for the 4 that was in the denominator of my first fraction, how did we turn it into 36?
Multiplied by 9.
Multiplied by 9. So what do I have to do upstairs?
Multiplied by 9.
Yeah. So what is my new numerator going to be? 9a. Right, and so now is the time when this feels a little bit different than when we did it with numbers, right? Just because when we do the same thing to the top and the bottom is still just a number, 36, but the numerator, because we multiplied a variable by a number, is still a variable expression upstairs. That a is going to stay a, right, for the rest of our problem. So upstairs we'll get 9a. What about the second fraction? To turn 9 into 36, what'd you do? Multiply by 4. So what should the new numerator of that second fraction be? 20, gotten by multiplying 5 by 4. And it's at this stage that we've done all the hard work, I think, that's involved in subtracting these two fractions. We identified the common denominator. First, we identified that we need a common denominator. We identified what that common denominator was, 36. And now we have brought both fractions' numerators up in an appropriate fashion to bring them into that common denominator. So we multiplied the 4 by what we needed to make it into 36 and did the same on the top. We multiplied the 9 by what we needed to make it into 36 and did the same to the top. So now our fractions have a common denominator. So how do you then finish the subtraction?
subtract the sign to the numerator.
Okay. Yeah.
And then you can, combine but don't combine them, like just keep one of both denominators.
Yeah, so that's I kind of like that that visual of taking the subtraction sign and just sort of nudging it upwards, right? What we end up subtracting is we end up subtracting the numerators from one another and leaving the denominator as it is. So my new numerator is going to be, well, it's going to have the 9a. This first term will have the 9a coming from the first fraction, and the second term will have the 20 coming from the second fraction. But then the denominator stays what it was. And so at this point, we've just done the subtraction part of our subtraction problem. Right? 9a minus 20, all divided by 36. Did you do anything from here? Why not? How do we know there's not something else we can do here?
Is there?
I guess that's what I'm asking. Is there anything else we can do to make this fraction any simpler? Elizabeth?
I actually did this. I tried to simplify it, but you can't because you don't have a common variable.
Yes, right. That's the reason I'm asking this question is it's very tempting. How did you try to simplify it out of curiosity?
I just straight, even just subtracted, and I got like negative 11 or 36.
Okay, so one tempting thing to do is to try and turn this numerator into negative 11a or something like that. Why doesn't that work? Why can't I do anything upstairs to simplify that subtraction? Yeah, the a is only in one of the two terms. So they're not like terms, which means we can't simplify their sum and their difference into only one term. There are some other tempting ways to try to simplify this. What might be another tempting way? Yeah. So this is often what people will try to do is, oh, well, 20 and 36, those have a 4 in common, don't they? So if I divide a 4 out, then this turns into a 5, this turns into a 9. What's wrong with that? Say again? Exactly. We can't be selective about that as far as the two terms go, right? If I divide a 4 out of this 20, I also have to divide a 4 out of this 9a. Right? We can't just do it to one term and not to all the other terms as well. And if I try to divide a 4 out of 9a, I'm going to get something nasty, like 9/4 a. So that's something not to do. Because there, again, you're trying to cancel something which is not a common factor in the numerator and denominator. If, on the other hand, we could simplify it, like let's say we could factor out a 5 in the numerator and denominator. Or I guess it was a 4, I just said, right? Let's say we could factor out a 4. Then that's what we would do at this stage, right? In the denominator it would be 9, and then in the numerator it would be something minus 5, whatever, 8a, just sort of making stuff up. Then we could cancel these 4s and be happy. But unless you can factor it out first, you can't cancel it. And if we try to factor out really anything from the numerator and denominator, we're going to have a hard time doing it. 9a minus 20, what's the greatest common factor between those two things? 1. The best we can do to factor anything out in the numerator is to factor out a 1, but that's not factoring anything at all. So there's no opportunity for us to factor out anything from the numerator. And therefore, there'll be nothing in common that's a factor to both the numerator and denominator that will help us to make this any simpler. All of which is to say that we can stop. You can't cancel it unless you can factor it first, unless it appears as a factor. And because we can't factor the numerator in any productive way, there will be no opportunity for us to cancel and make this fraction any simpler.